Welcome. What an incredible week it's been talking about game engineering. We dove deep into one of the most fundamental topics out there, design patterns. Day 1, what is design patterns? If you followed along, you know that game engineering isn't just about writing code. It's about building systems, reliable, performant, and maintainable systems that bring our aims to life. And design patterns are the proven blueprints that help us do just that, preventing us from getting lost in a mess of spaghetti code. So, we're going to take a whirlwind tour of 5 common patterns we can use. Let's get started. Day 2, the command pattern. We kick things off with the command pattern. Remember the problem? You want to implement an undo button, or maybe queue up a series of actions for an AI, and your code starts turning into a monster of if-else statements. The analogy we used was a restaurant. Instead of you, the customer, walking into the kitchen and telling the chef what to do, you write your order on a ticket. That ticket is the command. It contains everything needed to get the job done. The waiter takes that ticket and gives it to the chef. This simple act decouples you from the chef. In code, this means the object that initiates an action doesn't need to know anything about how that action is performed. So, instead of a waiter class that needs to know about every single possible dish, you create a general command interface. Then, specific actions like order pizza command or order burger command are created. The waiter can now just process a list of any command, executing them one by one without needing to know the difference between a pizza and a burger. And the real magic for games, you can easily add an undo method to that command. For an RTS game, a move command would not only know how to move a unit, but also store its old position so it can move it right back. It's an incredibly powerful way to handle player input, AI actions, and of course, that all-important undo-redo functionality. Day 3, the observer pattern. Next up, we talked about the observer pattern. This one is all about communication. Imagine you're an oracle predicting the location of a moving treasure island. Every time you make a new prediction, every pirate who's interested instantly knows about it and can react. It's just like subscribing to your favorite YouTube channel. You subscribe once, and from then on, you get notified whenever there's new content. We use the example of a smart bounty billboard in Cyberpunk's Night City. Without this pattern, every time the wanted target changes, the billboard's code would have to manually notify everyone. The police, the gangs, the bounty hunters. It's a nightmare to maintain. With the observer pattern, the billboard becomes the harbor subject. Any other object, like a police department, can register itself as an observer. Now, when the billboard updates its message, it just sends out a single notification. Hey, something changed. And every single observer that subscribed gets the message and updates itself automatically. The billboard has no idea who's listening, and it doesn't care. It just fires and forgets. This is perfect for things like achievements, UI updates, or event systems in your game. Day 4, the state pattern. On Wednesday, we looked at how our game objects can have mood swings with the state pattern. We used the perfect example, the cat from the game Stray. That cat doesn't always act the same. If it's in a sleeping state, patting it might make it purr. But if it's in a playing state, the same action, patting it, might make it pounce. And if it's in that 3 a.m. demon spawn state, who knows what will happen? The messy way to code this is with a giant if statement that checks the cat's current state string and then decides what to do. But as you add more and more states, that code becomes an unreadable tangle. The state pattern cleans this up beautifully. Instead of one big method, you encapsulate each behavior into its own separate state class. You'd have a sleeping state, a playing state, and so on. The main cat object simply holds a reference to its current state. When you tell the cat it's been patted, it doesn't decide what to do itself. It just delegates the action to its current state object. To change the cat's mood, you just swap out its state object. No more if ladders, just clean, organized, and easily expandable behavior. Day 5, the factory pattern. Then, it was time to become master craftsmen with the factory pattern. We imagine setting out on a quest in Kingdom Come Deliverance 2. Weapons can come from anywhere. You can craft them, buy them from merchants, find them in loot chests, or take them from enemies. The problem is, if you have code for creating a sword in all those different places, you're bound to make mistakes. The merchant code might create a sword with slightly different damage stats than the blacksmith code. It becomes inconsistent and hard to manage. The factory pattern solutions this by centralizing the creation process. You create a single weapon factory that knows exactly how to build every weapon in the game. Now, no matter where you need a sword, be it for a merchant's inventory or an enemy's loot drop, you just ask the factory. This gives you a single source of truth, ensuring every weapon is created perfectly every single time. But restrained Valiant Engineer, there's more. This pattern enables a powerful performance trick called object pooling. Think of it like a weapon rack. Instead of creating a brand new sword object every time and destroying it later, the factory can just grab one from a pre-made pool. When you're done with it, you return it to the pool to be reused. For games with lots of billets, enemies, or effects, this can be a huge performance win. Day 6. The component pattern. Finally, on Saturday, we learned to build our game objects like Legos with the component pattern. And what better example than Cal Kestis' customizable lightsaber from the Star Wars Jedi series? The old, clunky way to handle this would be through inheritance. You'd have to create a separate class for every possible combination. A red single emitter saber, a cyan dual emitter saber, a green crossguard saber. You'd end up with an astronomical number of classes. It's an inheritance inferno. The component pattern flips this completely. Your lightsaber object becomes a simple empty container. Then, you create small, independent, and swappable modules. A crystal component that defines the color and power, an emitter component that defines the blade style and damage, a hilt component, and so on. You can then assemble a unique lightsaber at runtime just by attaching the components you need. Swap out the crystal component, and the lightsaber's color and damage change instantly, with no code rewrites. This is the foundation of modern game engines like Unity and Unreal, and gives you incredible flexibility to create complex and dynamic game objects. And there you have it. Command, observer, state, factory, and component. 5 powerful patterns that solve common problems in game development, helping us write code that is cleaner, more flexible, and easier to maintain. Remember, these aren't rigid rules, they're tools. The goal is to understand the problem you're trying to solve and pick the right tool for the job. Thanks for joining me on this journey through 5 design patterns in game development. Of course, these are just the beginning. There are many more out there. My hope is that this recap gives you a solid entry point into exploring them further. If you'd like to go deeper, I highly recommend reading books like Game Programming Patterns by Robert Nystrom. I'll see you in the next one.